Hi, I'm Dave Cedarberg, the Outreach Coordinator for the Department of Physics and Astronomy at Purdue. We're going to talk about motion carts in motion. If you are one of the teachers to whom we are providing materials, I'll show you what you should expect to get and also what you'll need to provide on your own. And if you're going to provide your own materials, then this will be an example for that too. Everything will be written in the instructions, so you don't need to write this down. You will get a bag with some things, and you will get a box. The box is the Vernier Go Direct motion detector. We'll talk about that in a little bit, but you have a motion detector and a charging cord. And then you'll get a little bag that has the smaller parts. You will get a Hall's cart, which is just a motion cart. You will get about 15 to 16 feet of string. At one end of the string is a hook that will be for adding weights. We have a table pulley, and we'll provide you with some weights. We're going to give you some washers. You could use, obviously, anything you want. You don't really, for this lab, need to know the mass of these. They're just weights. Okay? I think, well, let me just say, in addition to these items, you will also need to provide yourself a piece of cardboard, some masking tape, probably a tape measure, meter stick, something to measure 3 to 4 feet. And then you will, excuse me, you'll download the Vernier graphical analysis software, and of course you'll need a device to run the software. Chromebook, computer, laptop, your choice. Okay? So there's the introduction. Let's go to the lab and we'll set this up. Okay, so let me demonstrate how I would set this up. My main idea is I would like the car to be able to accelerate, positively accelerate, and then negatively accelerate, and see that graphically in my data. So I would like to have a piece of string and a distance on the table that is greater than from the table to the floor, so that once the weight hits the floor, the force, the acceleration on the car in the positive direction will stop, and the car will slow down or negatively accelerate. So if my distance to the floor is, about 30 inches, then I need to be more than 30 inches back. But I want my string to be the distance from here to here. And so, knowing that this will hang over the pulley slightly, I'm going to say that's probably about right. So we'll cut the string. And we'll tie that up in a minute. The next thing I want to think about is the pulley on the table. I've run into two problems. The pulley, the jaw on the pulley is a little more than an inch, maybe an inch and a quarter. And that is not enough for some lab benches. It is for some, but others are thicker than that. And this lab bench doesn't even have an edge. So what I'm going to do, and you would need to provide this if it's necessary, I'll just screw this to a board and let my pulley go over the board. Okay, so that is one way around that. And I may need to take that down, so I will do that. The final thing is I want my motion detector to be about a foot, maybe a foot and a half behind the cart. So that would probably be pretty good. And then lastly, the surface area of this cart is not very great, and it won't be picked up sufficiently by the motion detector. That complicated with the fact that, you know, my lab partner is sitting here and there might be stuff sitting out. So what I'd like to do is just tape a piece of cardboard to the back of the cart to provide a little more surface area. So we can do that like so. And that will provide enough surface area to be picked up by the cart. Okay, we're going to set this up and we'll be back. So the first thing I want to mention is the GoDirect motion detector. You want to charge this before you use it. It charges just by plugging into the USB on your computer or any USB charging portal. To turn this on, just press the switch and it will start to blink red. Now, for the time being, we're going to set that aside and let's open up the software. So there we go, Vernier Graphical Analysis. And this is the opening screen that you will see. I'm going to select data collection or sensor data collection. And the software will look for any device. I will connect the GDX MD motion detector. And you will see up here at the top that that's what is connected, connected devices. And so I'll click done. And you will notice that now the detector is flashing green, which tells me that it is connected to the software. I am ready to collect data, and we will do that momentarily. Okay, we're almost ready to start. However, I want you to be aware that the cone of vision coming from the motion detector is about 15 degrees on either side of center. That means by the time that cone gets out to here, all this stuff is going to be picked up. And so I want to get rid of all the extraneous materials that might confuse the detector. That would include my computer, and I pushed it aside so that it shouldn't be in view. Now, a word about mass. If I'm not collecting data yet, but if I have the bare hook, I have nothing in the cart, and if I just let go of the cart, it will positively accelerate, but I won't be able to, it's going too fast, number one. The detector would pick it up, but I'd like a more gradual change between the positive and negative acceleration. So what I'm going to do is put a fair amount of mass in the car, and I don't even need any mass at all on the hook. There's enough mass in the hook itself to accelerate the cart. So I think we're ready. We'll get lined up. Now, if I were doing this with students in my class, I would have one student working the cart, one student working the computer. In this case, I'm going to do them both myself. However, I want to be as quick as possible letting go of the cart and getting my hand out of the way, because my hand will confuse the detector. All right, let's give this a shot. I'm going to let go of the cart and simultaneously hit collect. So, in a nutshell, that is motion carts in motion. I should also tell you that this lab is totally doable if you are a teacher that does not have motion detectors. These motion detectors are made by Vernier. They're about $100 a piece. They're very nice little devices. However, you can do this same lab with a measuring tape or meter stick and a stopwatch. When your cart is back before it starts, What's its initial velocity? 0. So I could take the distance traveled divided by the time, get meters per second. However, my average velocity is going to be the final velocity minus the initial velocity, and initial velocity is 0. So final minus initial divided by 2 will give me my final velocity.
Correction, that's average velocity.
And with a little algebra, you could also calculate the acceleration if that is appropriate for your grade level. So this is a very doable lab, even without the motion detector. Thank you.